Ah, time travel. The very thought of it sends shivers of excitement down our spines, doesn't it? To journey through the annals of history, to witness firsthand the events that shaped our world, or even to glimpse into the future. It's the stuff of dreams, of science fiction, and perhaps one day of reality. Imagine stepping into a contraption, a whirring, buzzing time machine, and being whisked away to a different era. The possibilities are endless, limited only by our imagination. But hold on a moment, dear reader. Before we get too carried away with this fantastical notion, we must confront a rather perplexing obstacle: the paradoxes of time travel. You see, tampering with the delicate fabric of time is not without its consequences, and these consequences come in the form of mind-boggling paradoxes that have puzzled philosophers and scientists for centuries. Don't worry, we shan't delve into the more esoteric realms of theoretical physics. Instead, we'll embark on a journey, a delightful exploration of these time travel paradoxes, examining their implications and the possible solutions that have been proposed. From the infamous grandfather paradox to the intriguing bootstrap paradox, we'll unravel the mysteries of time, one paradox at a time. So fasten your seatbelts and prepare yourself for a mind-bending adventure through the enigmatic realm of time travel. Let's start our paradoxical journey with the most famous one of all, the grandfather paradox. It's a scenario that's as simple as it is mind-bending. Imagine, if you will, that you, a daring time traveller, journey back in time to a period before your parents were even a glimmer in their own parents' eyes. Now, picture yourself encountering your grandfather, a sprightly young man who is yet to meet your grandmother and set in motion the chain of events that would eventually lead to your existence. In a moment of reckless abandon, or perhaps a fit of misplaced anger, you decide to erase your grandfather from the timeline, preventing him from ever meeting your grandmother. But wait. If your grandfather never had the chance to meet your grandmother, then your parents would never have been born, and consequently, neither would you. And if you were never born, how could you possibly have travelled back in time to erase your grandfather from existence in the first place? It's a paradox, you see, a self-contradictory situation that throws the very notion of cause and effect into disarray. The grandfather paradox highlights a fundamental problem with changing the past. It suggests that if time travel were possible, it would only allow us to observe history, not to alter it. Any attempt to change the past, no matter how small, would create ripples that could unravel the very fabric of our existence. How do we escape this paradoxical time loop? Some physicists propose a mind-boggling solution, the existence of multiple universes or a multiverse. This theory suggests that our universe is just one of many, each with its own unique timeline and set of events. In this grand multiverse, every possible outcome of every event exists in some alternate reality. Instead, you're creating a split in the timeline, branching off into a new universe. But while the multiverse theory is fascinating, it remains just that, a theory. Let's explore the bootstrap paradox. It's about origins and causality, where an object or information has no clear origin. Imagine finding a dusty book of beautiful poetry in your attic. You publish it and become famous. Later, you travel back in time with the book. You find the poet never existed. You give the book to someone in the past. And here lies the paradox. Where did the poems originate? The poems exist in a causal loop, with no clear beginning or end. Section 5. Time dilation. Time is not absolute. Now let's take a slight detour from the realm of paradoxes and delve into a fascinating concept that plays a crucial role in our understanding of time travel, time dilation. You see, time as we perceive it is not absolute. It's relative, meaning it can be stretched and squeezed depending on factors like speed and gravity. One of the most mind-bending predictions of Einstein's theory of relativity is that time slows down for objects that are moving at incredibly high speeds. The faster you move, the slower time passes for you relative to someone who is stationary. Imagine two synchronized clocks, one remaining on Earth and the other traveling aboard a spaceship at a significant fraction of the speed of light. When the spaceship returns to Earth after its high-speed journey, the clock on board will show that less time has passed compared to the clock that remained on Earth. This phenomenon, known as time dilation, has been experimentally verified and is a testament to the fact that time is not the rigid, unwavering concept we often perceive it to be. Time dilation also occurs in strong gravitational fields. Time slows down closer to a massive object like a black hole. So time is relative, a concept crucial to understanding the possibilities and limitations of time travel. Section 6. Wormholes, shortcuts through space and time. Now let's talk about wormholes, those hypothetical tunnels that connect two distant points in space-time. Imagine folding a piece of paper in half and poking a hole through it. That hole, my friends, is analogous to a wormhole, a shortcut that allows you to bypass the vast distances between those 2 points. In theory, a wormhole could act as a bridge, not just between 2 points in space, but also between 2 points in time. If we could somehow create, stabilize, and navigate these cosmic tunnels, we might be able to travel vast distances across the universe or even journey through time itself. However, the existence of wormholes remains purely theoretical. They are incredibly unstable and would require exotic matter with negative mass energy density to keep them open, something we have yet to discover. But the very concept of wormholes, however far-fetched, fuels our imaginations and provides a tantalizing glimpse into the potential for time travel. Section 7. The ethics of time travel. Can we change the past? The possibility of time travel also raises a plethora of ethical dilemmas. If we could travel back in time, should we? What are the moral implications of altering the past, even if it's with the best of intentions? Imagine, for instance, traveling back in time to prevent a tragic event, like the sinking of the Titanic or the assassination of a beloved leader. On the surface, such an act might seem noble, even heroic. But what about the unintended consequences? Changing the past, even in seemingly insignificant ways, could have ripple effects that we cannot possibly foresee. The people we save might have gone on to cause harm in other ways, or the events we prevent might have led to positive outcomes in the long run. The ethics of time travel are complex and fraught with uncertainty. It's a realm where the line between right and wrong becomes blurred, and the consequences of our actions are difficult, if not impossible, to predict. As we continue to explore the possibilities of time travel, we must tread carefully, mindful of the potential ramifications of tampering with the delicate fabric of time. Section 8. Overcoming paradoxes, science fiction or future reality. So, can we overcome these mind-boggling paradoxes? Is time travel merely the realm of science fiction? Or could it one day become a reality? The truth is, we simply don't know. The laws of physics, as we currently understand them, don't explicitly forbid time travel, but they do present some significant hurdles. The paradoxes we've explored highlight the potential dangers and inconsistencies of tampering with the past. They suggest that time travel, if it is indeed possible, might be far more complex and nuanced than we tend to imagine. Perhaps our understanding of time is flawed, or perhaps there are fundamental laws of physics that we have yet to uncover. Laws that govern the flow of time and prevent us from unraveling the delicate tapestry of cause and effect. Or perhaps, just perhaps, these paradoxes are not insurmountable obstacles, but rather intriguing puzzles, clues that could lead us to a deeper understanding of the universe and our place within it. Section 9. The future of time travel. Possibilities and limitations. While the paradoxes of time travel continue to boggle our minds, the pursuit of understanding time, its nature, and our potential to navigate through it remains a captivating endeavor. Whether time travel will forever remain in the realm of science fiction or eventually transition into the realm of scientific reality is a question that only time itself can answer. The journey of exploration is often just as exhilarating as the destination itself, and the quest to unravel the mysteries of time travel is sure to be filled with mind-bending discoveries and awe-inspiring revelations. For now, we can only imagine the possibilities and marvel at the intricate workings of the universe, a universe where time, the grand conductor of all things, holds the key to countless secrets waiting to be unlocked.